This is my geometry course. Today we're going to learn ratios, proportions, and triangle inequality theorems. You should recognize ratios and proportions from a previous course. We're going to review those topics because in the next classes we're going to be going over polygon similarity, similar polygons, and we're going to need to review that material before covering those topics. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start with triangle inequality theorems. Here are the first two theorems that we're going to need to know. These theorems look a little complicated, but when we do some practice problems, you're going to see that they're really actually pretty easy. So let's get started. It says list the sides of the triangles from shortest to longest. So we're going to do these first three problems together. What those theorems tell us is that the shortest side is the side opposite the shortest angle. I know that this side I'm highlighting blue here, I know that must be the shortest side because the angle opposite that side is the smallest angle. So that's the shortest side, so I'm going to list that CB. That's the shortest side. And then the next biggest angle is 59, so the side opposite that angle must be the next biggest side. So that would be AB. And then, of course, AC is the remaining side. So we listed the sides from least to greatest. So as you can see, this is not too bad. Let's try number 2. The side, the smallest angle is 22, so the side opposite 22 would be DE. So that's the smallest side. 63 is the next biggest angle, so the side opposite 63 would be the next biggest side. That's EF. EF. And then the biggest side is opposite 95 degrees, which is DF. So there you go. DE is the smallest side, EF is the next biggest, and DF is the largest side. We'll do one more of these together before you try one on your own. 25 is the smallest angle, so BC is the side opposite the smallest angle, so BC must be the smallest side. 65 is the next biggest angle, so the side opposite 65, AC, must be the next biggest side. And the only remaining side there is AB. It's opposite 90 degrees. So again, we're listing the sides of the triangles from least to greatest, or shortest to longest. So why don't you try number 4, and when you come back, we'll do it together. All right, we're back. The smallest side is opposite the smallest angle. So 18 degrees is the smallest angle, so the side opposite that is HI. That's the smallest side. The next biggest angle is 37. The side opposite 37 is GI, so GI must be the middle. And 125 is the biggest angle, so HG is opposite that. So that's the biggest side. So if you got that answer, good job. So why don't you try number 5, and when you come back, we'll do it together. All right, we're back. 40 degrees is the smallest angle, so BC, the side opposite that angle, must be the small side of the triangle. 69 degrees is the next biggest angle, so the side opposite that, BA, must be the next biggest side. And the biggest angle is 71, so the side opposite 71 is AC. So if you got that answer, good job. Go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. 42 degrees is the smallest angle, so the side opposite that angle must be the smallest side, and that is EF. 48 degrees is the next biggest angle, so the side opposite that angle, DE, that must be the next biggest side. And 90 degrees is the biggest angle, so the side opposite 90 degrees, DF, that must be the biggest side. So if you got those answers, good job. So now we're going to go to very similar problems. We just did problems relating to the triangle side inequality theorem. So that's this first theorem. If one angle in a triangle is bigger than another angle, then the side opposite the bigger angle is longer than the side opposite the smaller angle. But now we're going to go to the triangle angle inequality theorem. Now we're just going backwards. Now we're given the sides, and we're asked to list the angles of the triangles from least to greatest. So let's do the first three together. 5 centimeters is the smallest side, so the angle opposite that side must be the smallest angle. So we're going to list that angle first. That's the smallest angle. 6 centimeters is the next biggest side, so the angle opposite that side must be the next biggest angle. And of course, then we have angle B left over, and that is the answer. We listed the angles from least to greatest, and of course these are inner angles. We don't care about exterior angles in these problems. So let's see here. Number 8, the smallest side is 4 inches EF, so the angle opposite EF is angle D. That's the smallest angle. And 7.9 is the next biggest side, so the angle opposite 7.9, angle F, that's the next biggest angle. And of course that leaves angle E. Angle E must be the biggest angle because it's opposite the biggest side. All right, number 9. 57 meters is the smallest side, so the angle opposite the smallest side, angle J, must be the smallest angle. 63 is the next biggest side, so the angle opposite 63, angle L, must be the next biggest angle. And the biggest side is 71 meters, so the angle opposite the biggest side must be the biggest angle. And there you go. So you can see these problems are really not difficult at all. So now it's time for you to try. Go ahead and try number 10, and when you come back, we'll do it together. All right, we're back. The smallest side is 11 feet, so the angle opposite that side is going to be the smallest angle, and so on and so forth. I think you get the point. So if you got that answer, good job. Go ahead and try number 11, and when you come back, we'll do it together. All right, we're back. 3.77 is the smallest side, so the angle opposite the smallest side must be the smallest angle. And 5.82 millimeters is the next biggest side, so the angle opposite that must be the next biggest angle. And of course, angle B opposite the biggest side, 7.76 millimeters, that angle must be the biggest angle. Go ahead and try number 12, and when you come back, we'll do it together. All right, we're back. The smallest side is 8.99 kilometers. So angle B is opposite that side. That must be the smallest angle. And then 9 kilometers is the next biggest side. So the angle opposite that side must be the next biggest angle. And the biggest side is 9.1 kilometers. So the angle A opposite that side must be the biggest angle. So if you got those answers, good job. All right, so we're going to have to do some review on inequalities now. We learned these in my pre-algebra class, I believe, or possibly my beginning algebra course. I don't remember. We're going to solve these inequalities. These are called inequalities. They're not called equations. Okay, if we replace these symbols with equal signs, then they would be equations. But because these are not equations, because they're inequalities, we call them inequalities, not equations. But if you recall, we just solve these the same way that we solve equations pretty much. We're just going to isolate the variable, get it by itself. So we're going to subtract 3 from both sides. And then we're going to divide both sides by 2. And we're done. We solved the inequality. What this means is that x must be any number bigger than 3. So remember, when you solve inequalities, x can actually be an infinite number of values. Whereas with an equation, usually the variable is going to equal just one thing or maybe 2 or 3 things, a finite number of values, whereas in an inequality you can have an infinite number of values. Let's see here. So now I didn't show all the steps here. I didn't show actually what I was doing. I just showed the result of what I was doing. And the reason for that is this is a geometry course. You're expected to know how to do these steps on your own. So now let's subtract 1 from both sides over here. And then we're going to multiply. This is x divided by 4, and also there's a negative there. It might be easier to understand how we're going to get rid of that negative, because we don't want that negative there. We want x to be by itself. So we're going to move that negative down to the 4. It'll just be easier to understand that way. So we're going to multiply both sides by -4, because this is x divided by -4. In order to get rid of the division, you have to do the opposite of division, which is multiplication. So we're going to multiply both sides by -4, and we get x is greater than or equal to -16. The -4 here cancels out, and -4 times 4 is -16. But there's one thing that we forgot to do here. You may recall, whenever you multiply or divide both sides of an inequality by a negative, whenever you multiply or divide both sides of an inequality by a negative number, you have to flip this inequality sign. So right now it's -16 is less than or equal to x. It should be -16 is greater than or equal to x. So what this means is that x can be any number as long as it's less than or equal to -16. For example, -18 would work, or -16 would work because it can be equal, or -1000 could work. These are all solutions to that inequality. All right, so we'll do one more of these together. Actually, we'll do 2 more of these together before you try some on your own. Again, this is just to prepare you for some problems relating to our triangle inequality theorems. All right, in this problem we're going to combine the x's. -7x plus 1x is -6x. And let me go over that again. So we combine the x's, and then we're going to subtract 2 from both sides, and we get -6x is greater than or equal to 7. And then we're going to divide both sides by -6. Now remember, if you divide or multiply both sides of an inequality by a negative, then you have to flip the inequality. Notice how I flipped the inequality? It was, you know what, I don't know why I'm writing equal to. I'm sorry about that. Those should just be greater than and less than symbols. Sorry about that. Greater than, and less than. I don't know why I put a equal to symbol there. So again, when you divide by a negative, we had to divide both sides by -6. You have to flip that inequality sign, so don't forget that. And also I forgot to rectangle these. All right, so let's do one more of those problems together. Before you do one on your own, now we have a problem with parentheses. You may remember these problems. I think we did these in the previous class, or maybe the class before that, I don't remember, but we learned these in my pre-algebra course. When you have an equation or an inequality with parentheses, you first have to use the distribution rule to get rid of the parentheses. So -2 times x is -2x. -2 times 1 is -2. And 8 times x is 8x, and 8 times -2 is -16. All right, so we got rid of the parentheses. So now all we have to do is just, well, first of all, we're going to combine like terms. So -2 minus 4 is -6. We'll just rewrite the -2x. And 7 minus 16 is negative 9. And just rewrite that 8x. And now we have x's on both sides of the inequality. We have to get them all on the same side. So I'm going to add 2x to both sides. And I end up with 10x. And now I'm going to add 9 to both sides, and I end up with 3 is less than 10x. And I'm going to divide both sides by 10, and we get 3/10 is less than x. What this means is that x can be any value as long as it's bigger than 3/10. And that is the solution. Now, notice that I did not flip the inequality. The reason I didn't flip it is because I didn't divide by a negative number. I divided by a positive number. I divided by positive 10. Now it's time for you to try some of those inequalities. We'll start off with an easy one. Go ahead and try number 17, and when you come back, we'll do it together. All right, we're back. We're going to subtract 1 from both sides. And then we're going to divide both sides by negative 4. Now, because I'm dividing by a negative, I need to flip that inequality. And the final answer is x is less than or equal to negative 2. And so x can be any number as long as it's equal to negative 2 or less than negative 2. So for example, x could be negative 2, it could be negative 100, it could be negative 93, so on and so forth. So if you got that answer, good job. All right, go ahead and try number 18, and when you come back, we'll do it together. All right, we're back. I'm going to add 2 to both sides. Then I'm going to multiply both sides by 7. And that's the answer. So if you got that answer, good job. Go ahead and try number 19. And when you come back, we'll do it together. All right, we're back. We're going to combine these x's first. 3x minus 4x is negative 1x. Remember, we don't write the 1 though. You can write it if you want to, but it's traditional not to write it. And we're going to subtract 8 from both sides. And now we want to get rid of this negative. X is not isolated yet because that negative 1 is right in front of there. So we're going to divide both sides by negative 1. And because we're dividing both sides by a negative, we have to flip that inequality. And negative 4 divided by negative 1 is positive 4. So our final solution is 4 is less than or equal to x. And you can read it left to right or right to left. But just remember, when you say the inequality, it's always read left to right. So it's probably best to read it 4 is less than or equal to x. So x can be any number that is equal to 4 or bigger than 4. Let's see here. All right, try number 20. This is the last one of these inequalities we're going to do. And when you come back, we'll do it together. Remember, we have an inequality with parentheses, so the first thing you have to do is use distribution to get rid of those parentheses. Try number 20. When you come back, we'll do it together. All right, we're back. 2 times 3x is 6x. 2 times negative 4 is negative 8. And 3 minus 8 is negative 5. And add 5 to both sides of the inequality, and we get the following. Divide both sides by 6, and we get x is less than negative 2/6, which would just reduce to negative 1/3. So if you got that answer, good job. All right. So now we're going to go to the third theorem that we're going to learn today, the triangle inequality theorem. The name looks very similar to these names, so don't get confused by that. The triangle inequality theorem says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now I know that seems kind of complicated, so let's just go do some practice problems and you'll see what I mean by this. These problems are asking, is it possible to make a triangle with each group of side lengths below? In other words, if you have a triangle and these are the side lengths, is it possible to make a triangle with those side lengths? And then it says, if not, write the inequality that shows that it's not possible. So what this theorem tells us is that if you add two sides of the triangle, we have to do three inequalities. This is the first inequality. So if you add two sides of the triangle, those two sides, the sum of those two sides has to be greater than the third side. If that's not correct, then the inequality is that you can't make a triangle with those three sides. So does this work? Well, 10 plus 3 is 13, and it works. So it looks like we can make a triangle with these sides, but we have to do that 3 times. There's 3 different inequalities we can make here. Now we have to add let's add 10 and 8. And that has to be greater than the third side, the leftover side, 3. And is that greater? Is that sum greater? Well, obviously it is. 18 is greater than 3. So far it looks like we can make a triangle with these side lengths. But we have one more inequality to make. We can add, let's see here, we can add, what have we not done? We can add 3 and 8. So if we add 3 and 8, that sum has to be greater than the remaining side, 10. And we see that it is greater, the sum is greater. So what this proves is that we can make a triangle with these side lengths. So the answer is yes. So just to explain what's going on here, what are these sides? 10, 3, and 8. So let's say we have 10, and then we have 3, and then we have 8. So we can make a triangle with these, you see. But what if this side were 1? What if that side were only 1? Could we make a triangle with these side lengths? Well, you have 10 here, right? Then you know 8 goes out here, but 1, that's not big enough. You can't make a triangle with those side lengths. And so how do we know that? So this triangle here doesn't really represent reality. But what is the logic here? Well, if one side is 10, then these other sides, they have to connect. They have to connect, you see. But if these sides, if the sum is not at least greater than 10, then they're never going to connect. For example, let's say that this angle were really small. Let's say that this angle were really, really small, and this angle were really, really small. Then these numbers would be really close. This might be like 9, and this might be like 1.7. If you add these up, they're still bigger than 10, so you know that they can connect. But if you just keep making these angles smaller and smaller, eventually the triangle would just collapse. In fact, if this angle, let's say that this angle, or excuse me, this side were 9 and this side were 1, the only way that you could possibly make a triangle, the only way that you could connect these two sides is by making these sides kind of cave in here and collapse. And you would just have a line, you see. This might be a little longer in reality. I'm not really drawing these lengths exactly correct. So the absolute smallest sum that you can have has to be greater than 10. So that's why this triangle inequality theorem works. You can't make a triangle unless those two sides are big enough to connect. So that said, let's do some more of these problems, and you'll get the point. So our first, we have to try 3 inequalities until we find a possible contradiction. So I'm going to add these two. Let's try 5 plus 2. That has to be greater than the third side, and it is greater. So that works so far. And let's try 2 plus 2. That must be greater than the third side, 5, and that is not true. So instead of writing greater than, we write not greater than and write a line through it. And now we can say, no, you cannot make a triangle with these side lengths. So we don't have to even try the third inequality, partly because the third inequality would just be the same as this inequality, because 2 of the sides are the same, but also because we already found a contradiction. So we can just write not greater than, and you cannot make a triangle. If you have a side that's 5 and the other sides are 2, they're never going to connect. Even if you bring these sides down, they're not going to connect because these sides are 2. So if you bring them all the way down, even if you bring them all the way down, they're going to stop here. There's going to be a gap. You've got 2, 2, and this side is 5. So this gap here is going to be 1 unit long, and you're just not going to be able to connect those sides. So that's why this works. All right, so now, number 23, we're going to try each of our inequalities. 8 plus 7 has to be greater than 6, and that is correct. So far, looks like we can make a triangle. Let's try 8 plus 6. That must be greater than the third side, 7. And that's correct. That works. So far everything is fine. And what do we have left? We have 7 plus 6. That must be greater than the third side, 8. 7 plus 6 is 13, and 13 is greater than 8. So all of the inequalities work the way they're supposed to work. So can we make a triangle out of these sides? Yes, we can. So again, this stuff is it's not too bad. It's pretty easy. Now let's try 24, one more before you try one on your own. Let's try our inequalities here. 9 plus 5 must be greater than 4. Is that true? Yes, it is. So far we can make a triangle. And 9 plus 4, that must be greater than 5, and that is correct. So we can make a triangle so far. And now the last sum is 5 plus 4. 5 plus 4, is that greater than 9? And the answer is no, it is not. 9 is not greater than 9, so we put not greater than. And we say no. So in this example, we found a contradiction in the second inequality. In this example, we found one in the third inequality. When you find the contradiction, you can stop right there. You don't have to write every inequality. You don't have to write all 3 of them. As soon as you find an inequality that's not correct, you just say, no, you cannot make a triangle from those side lengths. So again, that's what this triangle inequality theorem tells us. The sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. And we're just assuming that if that's not true, you can't make a triangle. and the assumption is okay. Usually you're not supposed to make assumptions in geometry, but it's traditional that we just make that assumption. It's pretty obvious, I guess. All right, so now it's time for you to try. Go ahead and try number 25, and when you come back, we'll do it together. All right, we're back. So let's do our inequalities. 6 plus 2 must be greater than 9. Is that correct? No, it is not. Well, we're done. You can't make a triangle with those sides, so that was an easy one. Try number 26, and when you come back, we'll do it together. All right, we're back. Our first inequality, 4 plus 10 must be greater than 6. Is that correct? Yes, it is. So far, we can make a triangle. What about 4 plus 6? That must be greater than 10. Is 4 plus 6 greater than 10? No, it is not. It is equal to 10. It's not greater than. So can we make a triangle out of these side lengths? No, we cannot. Go ahead and try 27. And by the way, if you got these answers right, good job. Good job on those. If you didn't, that's okay. Just figure out what you did wrong. Try number 27, and when you come back, we'll do it together. All right, we're back. We're going to try our first inequality. 13 plus 5 must be greater than 12. Is that correct? Yes, it is. No problem there. What about 13 plus 12? That must be greater than 5. Is that correct? Yes, it is. So no problem there. And the third inequality, 5 plus 12 must be greater than 13. So is that correct? And yes, it is. So the answer is yes, we can make a triangle out of those side lengths. And sorry I went off the page there. Just ran out of room. So if you got those answers, good job. Try number 28, and when you come back, we'll do it together. All right, we're back. Let's see here. Try our first inequality. 4 plus 1 must be greater than 4. Is that correct? Yes, it is. So far, everything looks good. 1 plus 4 must be greater than 4. We already did that. So let's try 4 plus 4. That must be greater than 1. And that's obviously greater. So it looks like this is going to work. So can we make a triangle? Yes. So if you got that answer, good job. All right. So now we're going to do a second type of problem with this triangle inequality theorem. And again, if you didn't get a chance to get a screenshot of the triangle inequality theorem, go ahead and do that now. It says, if each pair of numbers below represents the side lengths of a triangle, write an inequality that shows the possible lengths of the third side, x. So we have these two numbers that represent two sides of a triangle. So we're going to say side lengths. The side lengths of the triangle we're going to assume are 12, 7, and the third side we're just going to say is x. So we want to know if you have two side lengths of a triangle, 12 and 7, what are the possible values of x? You might think, well, x could be anything. Well, actually, it can't be anything. You know, these two side lengths, they're written in stone. They're not changing. So you can't just choose any value for x. For example, let's say that you had 12. Say this side was 12, and this side is 7, right? Well, you can't choose like 1 for this side length because it's not going to connect. You can't make a triangle with side length 1. At the same time, you can't make a triangle where this side length is like 1,000 because think about it. This side is never going to connect. How is this? You have to connect this little endpoint with the endpoint up here. How is that possible? It doesn't matter how you rotate this side. You can rotate it over here. You can rotate it over here. You can rotate this one over here, this one over here. They're never going to connect. So if you define two sides of a triangle, you don't have an infinite number of possibilities for the third side. So we have to do our inequalities to see what are the possible values. 12 plus 7 must be greater than the third side x. So 12 plus 7 is 19. So this is very useful information. In order to make a triangle, we know that x has to be less than 19. Or if you want to read left or right, 19 is greater than x. So now we're going to go to a third inequality. To find some more information, let's take 12 and x. If you add those two numbers, that sum must be greater than 7. So this is the reason we did review on inequalities, is because we have to solve this inequality. If you subtract 12 from both sides, we get x is greater than -5. Now, we're going to do 3 inequalities here, just like we did in the other problems. But you're going to find that one of the inequalities in this case, it's not really useful. This inequality here, this gave us useful information. It sets a bound on x. X has to be less than 19. But this is not really useful information. So we're just going to kind of ignore that. It doesn't really tell us much that we can use. So now we're going to do the third inequality. We're going to say 7 plus x must be greater than the third side, 12. And we're going to solve that inequality, subtract 7 from both sides, and we get x must be greater than 5. Now that's useful information. This is useful information, and this is useful information, because now we have bounds on the possible values of x. So now we're going to write the final inequality. What we're going to do is we're going to take these two inequalities and we're going to combine them to write one expression. I think you did this in I can't remember if you did it in my beginning algebra course or my pre-algebra course. I don't remember if we did it a lot, but you can combine these. You can say x is between 5 and 19. That's just a fancy way of saying x is between 5 and 19. I know that's kind of confusing, but what this means is that x is greater than 5, and remember, if you forgot, Pac-Man wants to eat the bigger number. So that's a way you can remember. Pac-Man wants to eat the bigger number. So x is greater than 5, but x is less than 19. So what this means is x is between 5 and 19. X can be any number between 5 and 19. It can't be equal to 5 or 19, and it can't be less than 5, and it can't be bigger than 19. So that really is the final answer. It says, write an inequality that shows the possible lengths of the third side x. So that's what we did here. That's the inequality that shows the possible values of x. All right, so we're going to do 2 more of these together. So we're going to assume in this second problem that the sides of the triangle are 10, 13, and the third side is x. So by the triangle inequality theorem, we know that 10 plus 13, in order for this to actually be a triangle, 10 plus 13 must be greater than x. So that means that x must be less than 23 if you read right to left. Seems like all my inequalities are I'm reading them right to left, but technically you should read them left to right. So remember, it's easy to get confused with these inequalities. Just remember, Pac-Man eats the bigger number. All right, so that's valuable information there. Now we're going to do the second inequality. 10 plus x that must be greater than 13. Subtract 10 from both sides and we get x must be greater than 3. That's pretty useful information there too. And that's really all we need. We could do a third inequality, but it's not really necessary because we would just end up with x is greater than negative 3, and that wouldn't really tell us anything. So now we can write the final inequality. Final inequality. And that is x must be between 3 and 23. So x is greater than 3 but less than 23. All right, let's try one more of these before you try one on your own. Again, that's the useful information there, highlighted blue. All right, so side lengths, the possible side lengths, we're assuming are 6, 2, and the third length is x. So we're going to do our first inequality. 6 plus 2 must be greater than x. So that means that x must be less than 8. That's useful information there. And now we're going to do 6 plus x is greater than 2. And if we subtract 6 from both sides, we end up with x is greater than negative 4. That is not useful information. So we're just going to forget that. This is useful information. This is not useful information. So now we're going to say 2 plus x is greater than 6. And of course, if we subtract 2 from both sides, we get x is greater than 4. That is useful information. X must be greater than 4. We know that. So the final inequality is, let me move these over. The final inequality is x must be greater than 4, but it must be less than 8. So again, we're defining two side lengths of a triangle and saying what is the possible values for the third side. You can't just have any values. So that said, why don't you go ahead and try number 32. You have 11 and 5, two side lengths of a triangle, and you want to find the possible values of the third side, and I'm going to leave these in the window. So try 32, and when you come back, we'll do it together. All right, we're back. So we're assuming that the side lengths are 11, 5, and x. So now we're going to use our triangle inequality theorem. 11 plus 5 must be greater than the third side, and so x must be less than 16. And 5 plus x must be greater than 11. Subtract 5 from both sides, and we get x must be greater than 6. So we only need two inequalities and no negative numbers. If you get a negative number, you can just discard that inequality. It's not useful. So now our final inequality is x must be between 16 and 6. So if you got that answer, good job. I know it's confusing with these inequalities. If you change the direction of the inequality, for example, I can say 6 is less than x, or I can say x is greater than 6. These are both the same. But if I say 6 is greater than x, or x is less than 6, these are not the same as these. So it can be really confusing based on, what the order is. But remember, you generally always read left to right. 6 is less than x is greater than 6. Those two mean the same thing. 6 is greater than x, and x is less than 6. Those two mean the same thing. I know it's very confusing, but you just need some practice with this. This should be review. This should be review from previous courses, hopefully. If you took my courses, definitely review. All right, so try number 33, and when you come back, we'll do it together. All right, we're back. So we're going to assume that the side lengths of this hypothetical triangle are 2, 4, and x. And now we're going to use the triangle inequality theorem. We know that 2 plus 4 must be bigger than x. So we know that x must be less than 6. If you read right to left. Again, I don't mean to confuse you by changing from right to left or left to right. Now we know that 2 plus x must be greater than 4. Subtract 2 from both sides, and x must be greater than 2. So those are two very useful inequalities for us. I'm avoiding the third one. I can kind of tell what the third one's going to be because again, it's not useful to us. So the final inequality the final inequality tells us x must be greater than 2, but less than 6. In other words, it's between 2 and 6. So if you got that answer, good job. All right, go ahead and try number 34, and when you come back, we'll do it together. All right, we're back. We're going to assume that the side lengths of this hypothetical triangle are 27, 80, and x. And so the first inequality of the triangle inequality theorem tells us that 27 plus 80 must be greater than x. And by the way, it doesn't matter what order you do these in. You can do x plus 80 is greater than 27 first if you want. It doesn't matter. So we get 107 is greater than x, or if you flip it around, it's x is less than 107. That's a very useful inequality for us. Now, if my second inequality is 80 plus x is greater than 27, then you can see we're going to have a negative number. So we can just kind of skip that. It's not going to tell us anything. So we'll do 27 plus x must be greater than 80, the third side. Let's see here. So subtract 27 from both sides, and we get x is greater than 53. So the final inequality is x is between 53 and 107. So if you got that answer, good job. So as you can see, these triangle inequality theorems are really not that difficult. You may have a little trouble understanding, the principle behind it, but again, just use logic. If you have 5 and 11, right? Let's use this example here. You have 11 down here. You have 5. You need this side to extend out. If you rotate these sides down as far as they can go, they're not going to touch. And if you rotate them up, they're still not going to touch. If this side has to be big enough to connect to 5. At the same time, if you make this side too big, then it's not going to connect either. If you make it this size, it doesn't matter what you do. You can rotate this side over here. You can rotate it down. I may need to make this side a little bigger just so to demonstrate. you can rotate this down, but you know the triangle is going to collapse before you ever touch those end parts of those segments. So it's just based on really common sense if you think about it. All right, so we are done with triangles today. Those were problems involving triangle inequality theorems. But now we're going to prepare for the next big subject that we're going to cover, and that is similar polygons, similar triangles, similar quadrilaterals, all kinds of similar polygons. And to prepare for the similarity part of this course, we're going to review ratios and proportions. Now again, as I mentioned at the beginning of this class, these are all things that you've already covered, or you should be somewhat familiar with them. If you're not, then you'll probably get enough. You'll probably learn what you need to know as we do this review now. So let's get into it. We'll start with ratios, and then we'll go on to proportions. So a ratio is a relation between two numbers. For example, Don jumped 4 feet, and Tim jumped 3 feet. So there are 3 ways to make a relation with these two numbers. These are all examples of ratios. You can write it as a fraction, you can write with a colon, or you can write with the word 2. So you can say this is 4 over 3, or you can say 4 to 3, or you can say 4 to 3 with 2. And you can also flip them. You can say 3 over 4 and 3 to 4 and 3 to 4 and so on and so forth. Just be aware that these ratios are not the same as these ratios. If you change the order, they're not the same. So these are the 3 ways to write ratios. Again, ratios are just relations between two numbers. I know what you're thinking. You're thinking, well, who cares? I don't get why we need to write those numbers together. Well, these practice problems will hopefully give you an idea of why we care. It says here, I have $1 and you have $6. Write ratios of these two numbers in 6 different ways. So we'll do this one together. We can write as a fraction 1 over 6, or we can write 1 to 6 with a colon, or we can write 1 to 6 with the word 2. On the other hand, we can also flip these and say 6 over 1 with a fraction, 6 to 1 with a colon, or 6 to 1 with the word 2. And those are the possible ways to write ratios of 6 and 1. But just be aware that these ratios here are not the same as these ratios. Okay, they're all ratios with those two numbers, but these are not the same as these. They have to be in the same order. But these are all equivalent ratios, by the way. These are all equivalent, and these are all equivalent, meaning they're the same ratios. All right, so number 36. Why don't you go ahead and try number 36, and when you come back, we'll do it together. All right, we're back. You can say 20 over 11, 20 to 11 with a colon, or 20 to 11 with the word 2. And then, of course, you can flip those. Just doing the same thing, except the reverse order of the numbers. And there you go. So if you got that answer, good job. Again, we're just reviewing how to write ratios. All right, on to number 37. You know what? I think we can skip number 37. I think you got the point on that one. Well, actually, let's just go ahead and do it. The Kawasaki H2 supercharged motorcycle has 300 horsepower, while the ZX6R motorcycle has 107 horsepower. Write ratios of these two numbers in 6 different ways. Go ahead and try number 37, and when you come back, we'll do it together. All right, we have 300 over 107. We have 300 to 107 with a colon, and 300 207 with the word 2. And then, of course, we can flip and say in the reverse order, 107 to 300. And we're going to have to move these over. And we have 107 to 300 using the word 2. Sorry, my writing is so sloppy here. The computer is doing weird things with the pen here. All right, so if you got those answers, good job. As you can see, writing ratios is really not difficult. Now we're just going to reduce ratios. There were 8 gumballs in one bowl and 6 gumballs in another bowl. Write these two numbers as a ratio in lowest terms using a colon, then write the simplified ratio in 2 other ways. So I'm going to do this problem. It says using a colon, so I'm going to say 8 to 6 with a colon. But that's not lowest terms. We need lowest terms. So I'm going to write a little arrow here. And it's important to understand that you reduce a ratio the same way you would reduce a fraction, because again, a ratio is the same thing. You can write a ratio as a fraction. If you reduce that ratio, you get divide both sides by 2, you get 4 over 3. That's all that we're doing here. So we'd write 4 to 3 using a colon. So we have the simplified form of the ratio using a colon. But then it says write the simplified ratio in 2 other ways. So we can write 4 over 3 as a fraction, or we can write 4 to 3 using the word 2. So those are our answers. So again, we're just reducing that ratio, just pretending like it's a fraction. And by the way, you can write 6 to 8 also. That would have been an acceptable answer. 3 to 4, 3 over 4, or 3 to 4 with the word 2. So go ahead and try number 39, and when you come back, we'll do it together. All right, we're back. So 63 to 49, or you could write 49 to 63. Either way is fine. But we have to reduce that. It says lowest terms. So you notice that if we pretend this is like a fraction, you could just divide both sides by 7, and then we get 9 to 7. And then we can write 9 over 7, and we can write 9 to 7 with the word 2, and that is our answer. Again, you could write 7 to 9, 7 over 9, and 7 to 9 with the word 2. That's acceptable also. All right. So if you got that answer, good job. Now we're going to do some more reducing problems. It says write the following ratios in lowest terms. So I'm going to start off with these first 3. We're going to divide both these numbers by 5, and we get 9 to 5. And there you go. Really easy. Divide both of these numbers by 2, and we get 5 to 12. So this is really easy. Divide both of these numbers by 6, and you get 6 over 1. So we're just writing these ratios in lowest terms. So now you try number 43. 43 is kind of a tricky problem there. So maybe you should start with 28 over 21. We'll get to that tricky one next, or number 45. So try number 43. When you come back, we'll do it together. All right, we're back. Divide both sides by 7, and you get 4 over 3. So if you got that answer, good job. Go ahead and try number 44, and when you come back, we'll do it together. All right, we're back. Divide both sides by 10, and you get 1 to 2. 10 divided by 10 is 1. 20 divided by 10 is 2. And 45 is a little tricky, but see if you can do it. And when you come back, we'll do it together. All right, we're back. Divide both of these numbers by 26. 26 divided by 26 is 1. 26 divided by 26 is 1. And there you go. So you treat ratios the same way that you would treat fractions. The fundamental principle of fractions applies to ratios. So that's pretty much all we need to know right now about ratios, and we'll just move on to proportions now. So you can think of a ratio just as a fraction. You know, it's a relation between two numbers, and that's really what a fraction is. It's just a relation between two numbers. For example, if I say 3 over 4, that's a fraction, but it's giving you a relation between these two numbers. They're kind of related in a way. For example, if you have a pizza, a personal pizza has 4 pieces, and let's say that you eat, or let's say that you're looking at the pizza, and 3 out of the 4 slices are present there, and one of them is gone. So you have 3/4 of a pizza. Technically, that fraction is a relation between two numbers. One number is the possible spaces for all the pizza. That's the denominator. It shows you what size pieces you're actually counting. And then 3 represents the actual number of pieces that are there. So it's a relation between two numbers. That's what a fraction really is. Now, a proportion, that's when you set two fractions equal to each other. So you have to have 2 fractions for a proportion. Okay, so it says determine if the proportions are true. So in order for these proportions to be true, these fractions have to be equivalent. So what I'm going to do is I'm going to multiply both sides of this fraction by 4. 3 times 4 is 12. 4 times 5 is 20. Are those fractions equal? Yes, they are. So the answer is yes. That proportion is a true statement. Now, in this problem, I multiplied both sides of this fraction to get to this fraction. I can also reduce the bigger fraction sometimes, not every time, but in this case, I'm going to try reducing. I'm going to, let's see here. Actually, you know what? I'm just going to try multiplying again. So I'm going to multiply both sides of this fraction by 10. So 1 times 10 is 10. And actually, you know what? I don't want to confuse you. I think I'm going to do it a slightly different way. I'm going to multiply the denominator by 11. So 2 times 11 is 22, and 1 times 11 is 11. Again, we're using the fundamental principle of fractions. You can multiply both sides of a fraction by the same number. You should know that by now. If you're saying that you don't understand that, you have a big problem because you're in the wrong course. You should know the fundamental principle of fractions by now. If you need to review that, just go back to my arithmetic course talking about equivalent fractions and the fundamental principle of fractions. So I multiply both sides of this fraction by 11, and as you can see, this proportion is not correct. So we write not equal to, and we say no. The proportion is not true. So in this problem here, remember we multiplied both sides of these fractions to see if the proportion was true, but you can reduce a fraction sometimes. For example, I can divide both sides of this fraction by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And that's another way to figure out some of these problems. So we say, yes, they are proportional. These fractions are proportional. So just be aware of that. Now I want you to try number 49. And when you come back, we'll do it together. All right, we're back. So you can reduce this fraction, or you can multiply both sides of this fraction. In this case, it doesn't look like we can actually multiply this fraction to get, we can't multiply 5 to get 18, and we can't multiply 3 to get 8, so we're going to have to try to reduce this fraction, possibly. Sorry, I kind of gave you a curveball on this one. It looks like we can't really get a common denominator. We could get a common denominator by multiplying both sides of this fraction by 18. Then we would get 90 and what would that be, 54. So this is kind of these are kind of big numbers. Sorry I gave you a big number problem. Multiply both sides of this fraction by 5 and we get 40 over 90. So we can do it that way, and we can see that this proportion is not correct. I'm sorry I gave you such big numbers there, though. Number 50 is a little different because we can actually reduce both of these fractions. So let's try that together. I'm going to divide both sides of this fraction by 2 to get 5 over 6. I'm going to divide both sides of this fraction by 5 to get 8 over 9. So now we have numbers in lowest terms. But now we have to kind of go backwards and make the numbers big again. We're going to multiply both sides of this fraction by 3 to get 15 over 18. And both sides of this fraction by 2 to get 16 over 18. And we see they're not equal. So the answer is no. Those fractions are not proportional. So as you can see, there's a lot of different ways to see if fractions are proportional. Sometimes you can just change one fraction, sometimes you have to change both fractions, and you have to do multiple steps. So fractions are kind of tricky that way. There's a lot of different ways to work with them. So just be aware of that. But the most important thing to understand is the fundamental principle of fractions. That is, you can multiply both sides of a fraction, and it stays an equivalent fraction. Or you can divide both sides of a fraction and it stays an equivalent fraction. So try number 51, and when you come back, we'll do it together. All right, we're back. I'm going to divide both sides of this fraction by 5, and we're going to get 4 over 7. And both sides of this fraction by 2, and we get 4 over 7. Looks like we have a correct proportion. That proportion is true. So if you got that answer, good job. Try number 52, and when you come back, we'll do it together. All right, we're back. I'm going to divide both sides of 12/16 by 4, and we get 3 over 4. I'm going to divide both sides of this fraction by 3, and we get 3 over 4. So it looks like that is a true proportion, or a correct proportion. Now we're going to 53. Go ahead and try number 53, and when you come back, we'll do it together. All right, we're back. Divide both sides of this fraction by 9, and we get 8 over 9. Divide both sides of this fraction by 3, and you get 7 over 9. And you can see that that is not a correct proportion, so we would say no. So if you got those answers, good job. All right, on to number 54. This problem is a little different because you're going to end up with a whole number over here. Divide both sides of this fraction by 6, and you get 5 over 1. That's a whole number. And with this fraction, you can't really do anything. So we end up with 5 is equal to 4 over 13, which we know is not correct. So obviously no. Try number 55, and when you come back, we'll do it together. All right, we're back. So 9 divided by 3 is 3 over 1. 20 divided by 5 is 4 over 1. And of course, that just means 3 is equal to 4, which is not correct. So no, that's not, the proportion is not true. So we got that answer. Good job. All right, so now we're going to solve proportions. We're not seeing if the proportion is true or false. We're assuming that it's true. And we're then going to find the missing number. These are the most common types of proportions that you're going to see. So we have 8 over n is equal to 24 over 27, and we have to find n. This is asking us to find n. All right, so what we're going to do is we're going to reduce this fraction, divide both sides by 3, and we get 8 over 9. Now, if we're assuming that this proportion is true, then it's pretty obvious what n is equal to. Because the numerators are the same, the denominators must be the same also, so n obviously must be equal to 9 if we're assuming the proportion is true. Again, in the previous problems we did, we didn't assume it was true. We were asking if it were true. But in these problems, we're assuming it's true, so n has to be 9 in order for this to work. So what we did is we reduced this fraction, and then we could see that we had numerators that were the same, so the denominators must be the same also. A lot of different ways to do these. We're going to do the same thing here, and why don't you go ahead and try number 57. When you come back, we'll do it together. All right, we're back. I'm going to reduce this, divide both sides by 3, and I get 1 over 5 is equal to a over 5, and therefore, because the denominators are the same, the numerators must be the same also, so a must be equal to not 5, it must be equal to 1. So we got 1. Good job. A lot of different ways to do these problems. Let's see here. We're going to go ahead and reduce this fraction again, so try 58. And when you come back, we'll do it together. All right, we're back. We're going to divide both sides of this fraction by 7, and we get 6 over 9 is equal to 6 over b. So obviously, b has to be 9. We could reduce this fraction more, but why would we need to do that? Because we already have 6 in the numerators. So if you got that answer, good job. Try number 59, and when you come back, we'll do it together. All right, we're back. I'm going to reduce this fraction, divide both sides by 3. Sorry, my ends look like H's there. And we get, let's see here, 4 over 6, it looks like. So we can divide both sides by something bigger. Let's divide both sides by 6, then we get 2 over 3. There we go. So the numerators or the denominators are the same, so the numerators must be the same also, which means that n must be equal to 2. All right, number 60. If a bird flies 22 miles in 55 minutes, how long will it take this bird to fly 2 miles? Write a proportion statement and use it to solve this problem. So this seems pretty complicated, but it's actually really easy. We're going to make a proportion statement. We're going to write one fraction is equal to another fraction. Now the first fraction is this rate, 22 miles in 55 minutes. 22 miles in 55 minutes. The second fraction, it says, how long would it take this bird to fly 2 miles? Now, this is miles, so it has to be up here because the 22 is miles. We have to have miles, we have to have the same units on top and the same units on the bottom. So 22 is miles, so we have to put our 2 miles on top. And the missing number, it says how long would it take, so I'll write an H for how long it would take. So now we just have a proportion we have to solve. And that's how you do these particular types of problems. This is called a proportion statement. So that's the first part of the problem. Now we're going to use that to solve the problem. We just reduce this fraction, divide both sides by 11, and you get 2 over 5 is equal to 2 over h. And now, because we have 2's in the numerators, obviously the amount of time it would take to fly 2 miles would be 5 hours. And make sure you write your units on these word problems. So those problems are pretty easy. They look hard because they're word problems, but as you can see, it's just a proportion. Just set up the proportion. Make sure you set it up correctly. The error that a lot of students are going to make is that they're going to mix these up. Remember, if your miles is on top here, your miles has to be on top here. If your hours is on the bottom here, it has to be on the bottom here. That's the most important thing. So try number 61, and when you come back, we'll do it together. All right, we're back. 40 calories are required to run 90 feet. 40 calories in 90 feet. How many calories would be required to fly 9 feet? So 90 is the feet, so we know that 9 has to be in the bottom. And by the way, you could flip these. You could say 90 over 40. As long as you flip the other fraction also, you know, you're still going to get the same answer. So I'm just writing it in the order that it was read. So I'm going to call this, what are we looking for here? We're looking for calories, so I'm going to write C for calories. Divide both sides of this fraction by 10, and we get 4 over 9 is equal to C over 9, and obviously the number of calories is going to be 4. 4 calories, CAL is an abbreviation for calories. If you don't know that abbreviation, that's fine. You can just spell out calories. So if you got that answer, good job. All right, so now we have some problems that are a little bit different. In all the previous problems, we reduced this fraction. We just reduced it, and we used that reduction to lowest terms to figure out what the answer was, even though we didn't go to lowest terms in every problem. Now we're going to do something different. We're going to multiply both sides of this fraction by 2, and that's going to help us find the answer. So we get 18 over 8 is equal to 18 over n, and obviously n is equal to 8. So you can see there's different ways to do these problems. You just want to use whichever way is convenient. And for this particular problem, multiplying both sides by 2 was the most convenient method. So why don't you try that method? Well, let's go ahead and do 63 together. If there are 5 ounces of silver for every 2 ounces of gold, how many ounces of gold would be present with 30 ounces of silver? Write a proportion statement and use it to solve this problem. So again, this looks really complicated, but it's not. You just write a proportion. 5 ounces of silver for every 2 ounces of gold. How many ounces of gold would be present with 30 ounces of silver? So I know the 30 has to go on top because the 5 represents silver, and that's on top. And I'm going to write G for gold. So in this problem, just like the previous problem, we're going to multiply. We can't really reduce this because it's already reduced. We're going to multiply both sides by 6, and we get 30 over 12 is equal to 30 over G. So obviously G has to be equal to 12. So we're going to write an arrow up here. G is equal to 12, and we'll write OZ for ounces. OZ is the abbreviation for ounces. If you didn't know that, that's okay. Now you do. All right, so now it's time for you to try. Remember, you're going to multiply both sides of the fraction instead of dividing to reduce it. So try 64. When you come back, we'll do it together. All right, we're back. So I'm going to multiply both sides of the right fraction by 2 to get 16 over 14, and you can see that b must be equal to 16. So if you got that answer, good job. Try number 65, and when you come back, we'll do it together. All right, we're back. There are 2 gallons of red paint for every 7 gallons of white paint. How many gallons of red paint will be present with 21 gallons of white paint? And I'll say R for red. So now we're going to multiply both sides of this fraction by 3 to get 6 over 21 is equal to R over 21. And again, if we're assuming that the proportion is true, then R obviously must be equal to 6, and we're going to write GAL for gallons. If you don't know the abbreviation for gallons, that's okay. Now you do. All right, so number 66 is the same type of thing, so go ahead and try number 66. When you come back, we'll do it together. All right, we're back. So we're going to multiply both sides of this fraction by 10 to get 100 over 90. And obviously n must be equal to 90. So if you got that answer, good job. All right, so now we're doing some problems where you can't just reduce one fraction or multiply one fraction, both sides of one fraction by the same number. In these problems, that doesn't work because n is going to end up being some sort of a mixed number or some type of fraction. So in these problems, the easiest way to deal with this is just to probably cross multiply. And, you know, again, I don't know if I mentioned this, but one way you can do these problems is you're trying to isolate n, so we want to get rid of that division. We just multiply both sides by 5. That cancels out the 5, and you get n is equal to whatever 7/8 times 5 is. Now, if you multiply a fraction by a whole number, you just write the whole number as over 1. And remember, now you have two fractions. You're multiplying two fractions. Whenever you multiply two fractions, you just multiply the numerator straight across and the denominator straight across to get 35 over 8. So that's one way to do it. But I find that students, in this case, they just like cross-multiplying. And in fact, cross-multiplication works in every single case. The problem with cross-multiplication is, do you want to multiply 4 times 18? That's a big number. And so in some of these cases, it's better to just reduce or to multiply both sides of the fraction. But in this case, we can't do that. So we're going to do 8 times n is 8n, and 5 times 7 is 35. So 5 times 7 is 35. 8 times n is 8n. So this is just another way to do it. The easiest way to do it when we have numbers that we can't just reduce. This is fully reduced. We're not going to get a 5 in the denominator. And we're not going to multiply 8 by anything to get 5. So that's why when you would use this method. So now we just have to divide both sides by 8, and we get 35 over 8, as I mentioned before. Now, in my previous courses, I would want you to change this to a mixed number. So it'd be 4 3/8. But in this class, to be honest with you, I don't really care. You can just leave it as 35 over 8. That's not the point of this class, to teach you mixed numbers. All right, so let's do another one of these together. A times 4 is 4a. 5 times 6 is 30. Again, we just cross-multiplied. And divide both sides by 4, and we get 30 over 4. And if you want to change it to a mixed number, you can. 4 times 7 is 28. And we get 2/4, which reduces to 1/2. Now, if you're rusty on mixed numbers, again, you can go to my arithmetic course. So I want you to try number 69. And when you come back, we'll do it together. All right, we're back. 2 times b is 2b. 3 times 7 is 21. And divide both sides by 2, and we get b is equal to 21 over 2. And you can write it as a decimal too if you want, but if you write it as a mixed number, it would be 10 and 1/2. If you write it as a decimal, it would be 10.5. Either answer is correct. So if you got that answer, good job. All right. Try number 70, and when you come back, we'll do it together. All right, we're back. 5 times c is 5c, and 2 times 9 is 18. Divide both sides by 5, and we get 18 over 5. And just in case you want to know, that would be 3 3/5. All right, so if you got that answer, good job. Whoops, we forgot to rectangle that. Remember to rectangle all your answers. And that is the class today. Now, if you want to take screenshots of the work that we did today to help you with your homework or to study for tests, go ahead and do that now. This is screenshot number 1. Screenshot number 2. Screenshot number 3. Screenshot number 4. Screenshot number 5. And screenshot number 6. And remember, before you go, we need to get screenshots of your homework. If you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So here's a screenshot number 1 of your homework. And screenshot number 2. And screenshot number 3. So be sure to do that homework completely and correctly and neatly, and make sure it's in the proper order, the proper chronological order in your binder. So get that homework done, and I'll look forward to seeing you in the next class.